In this video, I would like you to have a good intuition behind the different joins that exist in SQL. So here we have two tables, table 1, table 2, which contain some random set of IDs. So table 1 here contains IDs 1, 2, 3. Table 2 contains IDs of which 1 is repeating twice, and then you have 2 and 5. You can obviously have a bunch of other columns as well, but the reason why I've only used these two columns is that we are going to be joining these two tables, table 1 and 2, on this particular column that I've shown. So this is irrespective of the other columns that actually exist in each of these tables. So let's have a look at the different outputs that you would get once you execute these different joins over here. The first join is the left join, which, like I mentioned before, is probably the most widely used join in industry as well as in academia. In this join, you would see that if we use the left join with the table 1 as our main table or as our left table, we would get on the left side over here all the elements or all the rows that are present in table 1. So you'll see 1, 2, 3 rather, which are all the elements which are present in table 1. You would also see element 1 repeating twice here. The reason for this is that in table 2, you have two elements, namely 1, that are being matched up to the one element in table 1. So that's why we'll see this 1 here being repeated twice, because it gets matched to two elements in table 2. We do not see element 5 here because it's not present in table 1. So ID or element 5 will not be present as a row here in a left join having table 1 as the main table. On the other side, conversely, if we look at the right join wherein table 2 is our main table, it's the same concept here, just that we are reversing the order of the tables. So now in this case, you would have all the elements in table 2 show up. And table 1 would be a table which we would join onto our main table, which is the table 2. And the elements that are present in table 2 would be 1, 2, and 5. Since 1 shows up twice and each of these 1s match up to the first row within table 1, we'll have 1 showing up twice over here. Each of these 1s would match up to one element in table 1, and then 2 matching up with 2. And then when 5 here, this is an interesting one. So 5 doesn't match up to any element in table 1, just like we had over here. 3 didn't match up to any element in table 2. So 5 here would show up as null. So this is an important conclusion. Even in the left join case, we had 3 not matching up to any element in table 2. Similarly, for a right join, we don't have any element in table 1 which matches to the element in table 2. However, since we have to show this element, it does show up as 5. However, since there is no match available to 5, it shows up as null. 3 doesn't show up in this table because it's not part of this table 2 that we are using as the main table in case of a right join. In case of a left join, the 5 will not show up, like I mentioned before, simply because 5 is not an element which is present in the main table, which is table number 1. So that's a very important distinction to recognize over here, that depending on which table is your main table, all the elements or all the IDs in the key of that table will show up in your final output table. So that's the important differentiation element between the left join and the right join. Inner join is simply where we have all the common rows showing up. So if you just look at the output here, we can see the couple of 1s that match up, as well as the lone 2 ID that matches with a 2 of table 2. And the 3 and 5 will simply not show up because there's no matching element in the other table to either 3 or 5. If you take the case of a full join, which simply means if you've done set theory before, you would have known that this is something similar to like a union. We would also introduce a union concept in a later exercise. But what this would mean is that you include all the elements of table 1, all the elements of table 2, and whichever elements do not match up, they're just shown as null. So for example, you include all the elements in the inner join. So full outer join will have all the elements whichever show up in the intersection or the inner join. So up till 2, 2, you'll notice that it's common. However, after 2 and 2, you'll notice that even though 3 doesn't match up, 3 in table number 1 doesn't match up to any element in table number 2, it still shows up here having a null value because it hasn't matched in table 2. And similarly, the presence of 5 in table number 2 hasn't matched with any element in table number 1. So it shows up as null. However, it does show up. So that's the difference between a full outer join and say a left or a right join, in the sense that it doesn't matter which is your main table here. All the elements of each of the tables would be shown irrespective of whether they're actually matching with any ID, in this case, to the other table. In this case, we have 3 elements matching and 2 elements not matching. So all of them will show up irrespective of the match criteria, whether that is met or not. The inner join will only match the criteria when it is actually meeting. Left join will match the criteria of the left table, and the right join will match the criteria of the right table. And I hope this video gives you a good intuition of how the different joins actually function.